Hello student, this is Ashish Vegadwa from Electrical Department. Today we will learn SCR, DIAC and Triac in brief in the subject Power Electronics. Let's move to the content of this topic. In this topic we will learn SCR and its characteristics, Triac and DIAC. Let's start with the first device, that is SCR. SCR means silicon control rectifier. It having three layers, two junction, and it having NPN and PNP transistor inside of SCR. So this is the construction diagram of SCR. It having two transistors, that is PNP type and NPN type. It having three terminals, that is anode, gate and cathode. So here we have connected base of PNP transistor with the collector of NPN transistor and collector of PNP transistor with the base of NPN transistor. So this is the internal construction of SCR. So if we supply gate pulse to this NPN transistor, then NPN transistor will turn on and it will try to pull up collector current from the supply. But here we have connected collector of NPN transistor with the base of PNP transistor. So it will trigger the PNP transistor because PNP transistor require negative pulse. So collector current of PNP transistor will flow. Due to combined effect, both the transistor will on. So SCR will turn on and it will take forward current from the supply. On DC supply we have to turn off SCR manually, but on AC supply SCR will turn off automatically. Let's see the characteristics of SCR. As per this diagram, we have taken forward supply voltage on x-axis and forward current on y-axis. The total three terms are very important in the characteristics of SCR, that is forward breakdown voltage, latching current and holding current. The first term is forward breakdown voltage. After some forward voltage, SCR will turn on. It is called the forward breakdown voltage. In the diode, forward breakdown voltage may be 0.3 or 0.7 volt. But in SCR, rating of forward voltage may be 1 to 1.5 volt. During forward breakdown voltage, only leakage current will flow through the supply. Second term is latching current. This latching current is involved with the on process of SCR. So current required to turn on the SCR is called the latching current. And the second is holding current. This holding current is related to off process of SCR. When current passing through the SCR will below the holding current, the SCR will turn off and SCR will only operate in forward region. It will not operate in reverse region. When voltage across SCR in reverse bias is greater than reverse breakdown voltage, then SCR will damage and we have to replace the SCR. Let's see the next device, that is Triac. Generally Triac is 5-lever device that is able to pass current in bidirectional. It means current will flow in both the directional and therefore behave as an AC power control device. The main connection are simply named as MT1 and MT2. It having two terminals, that is MT1 and MT2. Triac can be considered as a two thyristor connected in anti-parallel. The single gate terminal is common to both the thyristor. The main terminal MT1 and MT2 are connected in both the P and N type region of the device. This is the internal construction of Triac. It having two SCR connected in anti-parallel, that is PN, PN and NP, NP. So we have connected gate at both the terminal of SCR. It is on P type material and it is on N type material of second thyristor. And both the thyristor are connected in anti-parallel. So we have supplied MT2, MT1 and gate terminal. So this is the symbol of Triac. Generally Triac is used in fan regulator. Let's see the brief about Triac. Device polarity is usually described with reference to MT1, where term MT2 plus denotes that terminal MT2 is positive with respect to MT1, and Triac, it means triode for alternating current. It means it will operate only on AC current. It will not operate on DC current. Triac is 5-layer and 3-terminal power semiconductor device. It has pair of phase control SCR connected in inverse parallel manner on same chip. It is a bidirectional device, means It can conduct current in both the directional. Whether we have supplied positive or negative gate signal, it will conduct. Physically, triac is not comprised of two SCR connected in parallel, but it is only function as two inverse parallel connected SCR connected on AC supply, and it is operate only on AC supply. It will not design for DC supply. Generally, maximum rating of triac, it is in range of 16 kW. Let's see the next device, that is DIAC. DIAC means diode will operate on AC supply. It having two electrodes. It is member of thyristor family. It is mainly used to trigger SCR or to trigger triac. Generally, it is widely used to trigger the triac. The advantages of using this device is that it can be turned on or turned off, simply reducing the voltage level below its average breakdown voltage. It may be 29 or 30 voltage, depends on rating or depends on type of the DIAC which we have used. Also, it can be either turned on or turned off both the polarity of voltage. This device works when avalanche breakdown will occur. The DIAC is basically two terminal parallel inverse combination of semiconductor layers that permits triggering in either direction. It means in both the direction. There is no control on this device. It means it not having base terminal or gate terminal, and physically it looks like a regular semiconductor diode. Let's see the characteristics and symbol of DIAC. So it having four region total: quadrant 1, quadrant 2, quadrant 3 and quadrant 4. On x-axis we have taken supply voltage. It is forward voltage and reverse voltage. On y-axis we have taken forward current and reverse current. So forward current will flow in positive direction and reverse current and will flow in opposite direction. As per the characteristics of DIAC, it will operate after the forward breakdown will occur, and it is the VBR. The voltage across this DIAC, it is about 29 to 30 volt. Up to the forward breakdown voltage, DIAC will not conduct the current, or it will conduct the current only amount of leakage current, that is ION, that is shown here. And after the forward breakdown voltage, DIAC will turn on and it will try to conduct the current in both the directional. If we apply forward voltage, then after the forward voltage, it will conduct the current and it will very high. Also, it is operate in reverse direction. So up to the minus VBR voltage, it will conduct the current only of leakage current. After the minus VBR voltage, it will conduct very high amount of current. So DIAC will operate in first forward region and reverse region. It is of quadrant 1 and quadrant 2, and this is the symbol of DIAC. It is shown like two diodes are connected in anti-parallel. Let's see the question for assignment. First question is that explain following device in brief, that is SCR, Triac and DIAC. Thank you.
If you like this video, please subscribe and like our YouTube channel LJB Electrical, and don't forget to click on the bell icon to get latest video update fast.